Hello, welcome back. In the last video, we covered single producer, single consumer channels in Rust. Today, we are stepping it up to multiple producer and single consumer, also known as MPSC. This is one of the most concurrency pattern in Rust, and it's super useful for parallel workload. So, for example, if you want to create logging in your project, and you know that multiple applications are logging, and you know that. While on the other hand, there it would be a serial console or your terminal is as one application who will receive everything and have to print there. So this is one of the example where you can have multiple producers because you have a lot of applications and a single consumer because there is only one application which can print these logs. Right. So how does the multiple producer and a single consumer look? So if you see this, there are more than one producers and they give the data to the channel. And while one of the consumer on the other side receive the data from the channel and process it. So let's write the code for it. You will see that the code would be very similar to what we have done in the previous video. So if you want to practice that code, you can always take the code from the previous channel, but in this video we are going to write it from the start. So what are the three libraries we are going to use is MPSC, which is used for creating channel. We are going to use our thread library, which will we use to create our two producers and one consumer. And the last time we are going to use our time library, which is similarly the same, but why we are going to use time is to basically to specify the duration. So the thread can sleep, right? Duration, this one. And then we don't need use code.time. Now, to write our main function, we have function main. Unfortunately, I deleted that as well. So I'm going to write it again. Now, we are going to start with the same thing. We are going to get our tx, rx, and they will be created from MPSC channel. And then we are going to get our tx.1. Basically what we are going to, as we need two producers, basically we need two transmitters. So we are going to clone our transmitters. So we are going to use tx.clone here. And this is how we are going to clone our transmitter. So let's create the first producer. Producer 1 is equal to thread : spawn. And then we are again going to write like move. And then we are going to write this. So basically this will be our anonymous function, and how we are going to write the function is that for I in 1 : equal to 3, and then tx dot send our I and dot unwrap, because as I told you that this is a function which returns you an error, so we are going to see that everything is correct. Okay, and then we are going to use our thread dot sleep : sleep, and duration from millisecond, let's say 300 or let's say 200. Okay, and we are going to use our println function, writing pro producers producer I, and we know that this is the first producer, right? Producer 1 produced I. Perfect. Right, now we are going to do the same thing. We need a semicolon here, and then we are going to copy the whole thing, because as we are going to create our second producer, which is basically the same, but it is not going to use tx, it is going to use tx.1.send, right? Because they both cannot use the same transmitter queue. So they're going to use a different transmitter called tx1, which you have seen that we have cloned it from tx. If you don't understand clone, it means basically a copy. Now we are going to create our consumer. Consumer is also the same. We are going to write a consumer and then basically create a new thread. Consumer is equal to thread spawn move, and then our function starts from here, and we say while let okay value is equal to rx dot, as we have only one consumer, it's going to be rx dot receive, And then it's pretty simple. Here we are going to write, here we get this producer2 dot produced, and let's say the time would be 600 milliseconds. So you will see the difference between the logs, like one thread is sleeping for 300 while the other thread is sleeping for 500. Here consumer consumed value. Now the last thing which we need is to basically producer1 dot join dot unwrap, producer2 dot join dot unwrap, and consumer dot join dot unwrap. So basically why I'm doing this again, if you remember it correctly in our last video, that when we enumerate thread, a new thread is created from the main function. What we want is that the main function should wait till all the threads are completed. So basically if we don't do this, the main function will never wait for the threads to complete and will really exit very early, so you won't see the output. So basically you have to create the join statement so that the main thread wait for all the threads to complete first and then only finishes it. Okay, now let's do our cargo run here and let it take time to build. And now you can see is that producer1 produced thing and producer2 produced one. They are producing at the same time because they both start at 0 millisecond. Now consumer consumed 1 and consumer consumed 1. So it doesn't matter which it consumed, but basically it went to the queue and the consumer consumed. Now producer1 produced 2, consumer consumed, like the consumer queue consumed. Then you know that the producer2, the thread is sleeping for 600 millisecond while this thread is sleeping for 200 millisecond, and that's why the producer1 completed the 3 while the consumer consumed. And then the producers who woke up did 2, consumer consumed, did 2, and consumer consumed. So this is how your multiple producers consumer, like the multiple producer and single consumer concurrency pattern works. So now to brief, I will summarize it once again. So we have created a channel with MPSC. We clone the sender so multiple producer can push into the same queue. Both producers threads send independently. So they're not, these two, producer 1 and producer 2, are not dependent on each other. They are independent. The consumer listens and produces message one by one. And this is a magic in that Rust ensures everything is memory safe and trace free. The thing is this, MPSC channel already implements mutex for the senders. So that's why we don't have to implement the mutex separately. Otherwise, if two producers are writing into the same queue, they have to have some synchronized mechanism like mutex is atomic so that they ensure that the write is safe. But Rust makes sure, the MPSC channel makes sure that the writing is safe. Now, just remember few interview follow-ups. The first thing is that what happens if the consumer is slow than the producers? How could you make the channel bounded? And then in the next video, we are going to see that how we can implement the multiple consumer problem. So that's multiple producer, single consumer channel in Rust. It is one of the most simplest but most powerful concurrency tool that you will use. Next time we will look into multiple consumer patterns and more advanced synchronization techniques. Don't forget to like, subscribe, and drop a comment if you want to cover custom log free queues in Rust as well. Thank you so much and have a nice day.